Okay, let's do the lesson 8 practice problems for 7.4. And we'll start with the warm-up here. It says, Maya walks 12 miles. Then she walks an additional 1/4 of that distance. And we circle all the expressions that represent how far she walks altogether. So the first one here says 12 plus 0.25 times 12. So this 0.25 times 12 would get us that additional 1/4 of the distance, because 1/4 equals 0.25 or 25%. So 0.25 times 12 is going to get us that extra distance. B does the same thing for us, because hopefully you remember the distributive property from 6th grade, where we're going to take this 12 and distribute it to the two things being added in the parentheses here. So 12 times 1 is 12, and 12 times 0.25 achieves the same thing that it did here. So this is another good one. We're circling A, we're circling B. And then C says 12 times 1.25. 12 times 1 is 12, and 12 times 0.25 is the same as we've done in the other expressions. And so this one would also work for us. D and E, on the other hand, would not. D just does the 12 times the 0.25. So this only gets us the additional 1/4, but not the initial 12. So that doesn't work for us. And then E isn't even close. Instead of adding 1/4 of 12 onto 12, it's just adding 1/4, and that doesn't get us what we want. All right, before we go any further, I would suggest writing these 3 equations on your paper, because these are the 3 equations that we're learning in class right now, the 3 equations that are relevant for these questions and for your upcoming quiz. It's going to be, if you need to find the original value, that equals the new divided by the percent. But we have to be really careful about what percent we're using, and we'll talk about that through the video. If you need the new value, then you should be doing original times percent. I'm going to abbreviate that because I ran out of space. And then if you need the percent increase or decrease, which I'll just make an arrow there for that, that's bigger number minus smaller number, all divided by the original. So let's see if we can use these on some of these questions here. It says, in a city in Ohio, the sales tax is 7.25%. I'm going to convert that to a decimal right off, because I know I'm going to need that as a decimal, and might as well just get it out of the way. So move that decimal point 2 spaces, 1, 2. We wind up with 0.0725. So now to find the sales tax off of either of these two prices, I'm just going to times by 0.0725. So let me grab this. 8 times 0.0725. Looks like it's 58 cents. 0.58 in this case is 58 cents. And then 24 times 0.0725 is $1.74, it looks like. Now, notice to go from price before tax to tax, we multiply. So to come back the other way, if we know the sales tax, let's divide by our tax rate to figure out what the price must have been. So $1.16 divided by 0.0725 equals 16. And then to get the price including the tax, we just add the two, right? The price plus the tax. This will be $25.74. And this one will be $17.16. Now, what we did here is we found new numbers. These are all new in this column. after increasing by 7.25%. Up here, it says if you want to do that, you should do original times percent. Well, this percent is the percent increase plus the original 100%. All of these numbers here are considered 100%. So if we took 100% plus 7.25%, which is 107.25%, or as a decimal, 1.0725. So this is 100 and then 7.25%. And we times that by the original price, like let's try the 8. We would get straight to this final answer here, 8.56. And so these are just two strategies of handling this type of question. Okay, so it says a family eats at a restaurant. The bill is $42. The family leaves a tip and spends $49.77 total. How much did the family tip? Well, let's find the difference. $49.77 minus 42 is $7.77. Notice that I took the bigger number and subtracted the smaller number. That's exactly what this equation here for percent increase and decrease says to do first, bigger minus smaller. And then the next question asks, let me change this a little bit. How much is the tip as a percentage of the bill? So we want to know, like, how much did they increase their bill by as a percent? Well, we already did bigger minus smaller. Now let's divide the result of that by the original. We're essentially doing this formula here, but in two steps. This was step 1. Step 2, let's take the $7.77, divide by the original 42, 7.77 divided by 42. So we get 0.185, but that's a decimal. As a percent, we move that decimal point over 2 spaces and get 18.5%. All right, next it says, if the store buys, the music store buys instruments and then sells them for 30% more than they paid. So that's a 30% increase. So right over here off top, I'm going to do a little side work. The original number, or like the cost that they pay for the instrument, is always 100%. And then they add on an additional 30% so they can make profit. So that's 130%. And then we're going to need this number as a decimal to do some math with. So it's 1.3. So I'm going to keep this number handy for me to work. If the store buys a guitar for $45, what will the store sell it for? So we have the original number here and we need the new. That's this. New equals original times percent. But the percent I'm using is the 130%, aka the 1.3. So 45 times 1.3. And I'm going to let you get that answer. Here it says, if the price tag on a trumpet says 104, that means they're selling it for 104. How much did the store buy it for? So we work backwards. When we knew what the store paid and we wanted to see what they're going to charge, we times by 1.3. But now we have the new price, right? What they charge for it. And we need to find the original price they paid for it. Sorry, we need to find the original price that they paid for it. So we're going to do new divided by percent. We're essentially just working backwards. So this one should be 104 divided by 1.3. Another way to think about this is that there's some original price, like some price that they buy the trumpet for, and they increase it by 30%, or they multiply it by 1.3 to get a price tag of $104. And so it's something times 1.3 equals 104. And so to work backwards from that, we do 104 divided by 1.3. This is going to get your original price that the store paid for the trumpet. And I'll let you get that answer as well. Okay, and then the last one here at the bottom of the page is like a two-step one, similar to in the Desmos percents machine lesson, they have like 2-stage machines. This has 2 stages. It says during a 20% off sale. So first of all, I'm going to handle this 20% off. The regular price is 100%. When you take 20% off of that, you have 80%, which equals 0.8. So in order to figure out what the regular price of the clarinet is, I'm going to take this sale price of $96.30, which is a new price because it's like after this discount. And I'm going to do the original price equals the new price divided by this percent. So this new price divided by 80% or 0.8. This is going to get me the regular price that they normally charge for this trumpet. So let's see here, 93.60 divided by 0.8. So normally they charge $117, but we're only halfway done here because it says how much did the store pay for the clarinet. So we've already done this once before though. In the previous question, it said that the trumpet was 104, and to figure out how much the store paid for it, we divided by 1.3. Same thing. We're going to take this, we're going to consider this our new price now, divide by our percent to get the original price that the store paid for the clarinet. I'll let you get that final answer there. Here at the top of the next page, it says the sales tax rate in New Mexico is 5.125%. Circle all the equations that represent the sales tax T that you would pay for an item that cost C. So here that we're being asked to show what we know algebraically. Instead of just being able to answer questions, can we write an equation with letters that says the same thing? We call this generalization in math. Well, first off, I'm going to convert this percent to a decimal. This is 0.05125. Yes, I see it has a decimal in it, but when I say converting to a decimal, I mean a representation of this number without the percent symbol. And so all I did was I moved the decimal point over 2 spaces to get 0.05125. And so now the only ones that have a chance of being correct are the ones that have 0.05125. Not this one, has the wrong decimal. Not this one, has the wrong decimal. This one and this one have the correct decimal representation. And actually, so does this one, because 5.125 divided by 100, dividing by 100 would move that decimal point 2 spaces over and give us the right decimal. And so now this one and this one say you should take the decimal and multiply it by the cost to get the tax. This one, on the other hand, says you should take the cost and divide it by the decimal to get the tax. That would be incorrect. If we want to know 5.125% of the cost, then we do 5.125% times the cost. So these are the only 2 that work. Lastly, it says a pair of pants in New Mexico costs $30 before tax. So that's our original price. How much does a pair of pants cost after tax? So there's a couple ways you could answer this, but I'm going to answer it using this equation here. I want to find my new, and I'm going to do original times percent, but that percent is going to be the 100% from the original plus the 5.125% tax. So I'm going to put those 2 things together to make 105.125%. But then when I move the decimal point 2 spaces, as a decimal number, this is 1.05125. If I take that number and multiply it by my original price, I'll have the total cost, and I'll leave that for you to finish solving. And I'll leave the Explore for you to try. Remember, the rule on the Explore is you don't necessarily have to finish or solve it all the way, but you got to at least try it.